Welcome children to this session of Standard 9 Subject Geography, Lesson number 6, Properties of Seawater. In the temperate region, the sun rays are slanting and the temperature are lower. Because of the melting of the snow, the supply of water is also more. In this zone, the salinity decreases with increasing latitude. In the polar areas, the temperature is very low. Evaporation is also less in the polar area, so salinity is low. Landlocked seas have higher salinity than the open sea, as the rate of evaporation is more. See, here is an image, children, where is the landlocked sea. So landlocked sea have higher salinity. Why? Because the amount of water gets evaporated very easily and very faster as it is exposed to the sun, and the amount of salt remains here only. So in the landlocked sea means it has been covered from three sides by the land. So that is called as landlocked sea. So in landlocked sea you have a higher salinity than the open sea. Open sea doesn't have the higher salinity because the water keeps on flowing from all the direction and the fresh water keeps on entering in it. So the salinity becomes very less as the amount of fresh water will be more. Thus there is a difference in the salinity of the open and the enclosed sea. For example, the average salinity of the Mediterranean Sea is 39 degrees Celsius, while the salinity of the most saline ocean, the Atlantic Ocean, is 35. You can see this middle image is of Mediterranean Sea and this is of Atlantic Ocean. Atlantic Ocean is 35 degrees Celsius because it is open from both the ends, from northern and the southern part. Whereas the Mediterranean Sea, it has been closed from all the side by the land. It is situated in between. So it has the highest salinity here. Let's see density in detail, children. Temperature and salinity are two properties of seawater that controls the density of seawater. If temperature reduces, density of water increases. Cold water is denser and so is saline water. As compared to the salinity, temperature affects density more. Sometimes more saline water has lower temperature, affects density more. Sometimes more saline water has lower temperature at the surfaces. The density of such water more than the other water. On the contrary, seawater having higher temperature and low salinity can have lower density. To prove this, we have an example down, children. Just see this experiment. First one is the hot water, where you can see the flame down and just see the water molecules, which is given in the form of the blue bubbles. Where the water is hot, the water molecules are away from each other. Whereas in the second case, the room temperature water has been shown. In the room temperature, the water is little bit warm. We cannot say it's hot nor chilled. So the water molecules have come little bit closer to each other. And in the third case, when the water is totally chilled, the water molecules have come very closer to each other and they are very tightly fixed up. So this shows that the water molecules are very, very close in the C section. So here in the hot water, molecules are away. In the warm, they are little bit closer to each other, and in the chilled one, they are very close to each other. If we want to see the density of the seawater, how it is, just see the second image. We can see two different types of water. What is shown in the screen? That is the open sea and the dead sea. The black color water which you can see, children, is of dead sea, and the grayish color water is of open sea. It shows the salinity of seawater. Where the dead sea is in black color have the high salinity, where the grayish color water is lighter and have low salinity, because the fresh water is mixed in it and the salinity is less. Cold water has the high salinity as compared to the hot water, and if the salinity is more, density is also more. So temperature affects the density more than the salinity, children. If we talk about, sometimes more saline water has low temperature but density is more, whereas seawater having the high temperature and low salinity have lower density. So in short, we can say when salinity is more, density is more. When salinity is less, density is less, children. See children, as you can see the graph on your screen, there is a graph for the temperature, salinity and density. As you can see the three different graphs which has been shown on the screen here. The depth is in the 1000, 2000, 3000 and it goes on increasing. And the temperature starts from the 0 degree to 30 degree and salinity from 34 to 38, whereas density from 1024 to 1038. So here we can see the three different graphs. Temperature at 0 degree Celsius between 20 to 24. As we are going deeper and deeper, temperature gets reduces. You can see it starts from 20 to 24. The red line is getting start, and as we go deeper, like from 1000 to 2000, then below the 2000, 3000, and as we go the deeper, the temperature keeps on getting reduced because the curves comes near the 5, and after that 5 it becomes stable. So this shows that as we go down up to the 2000 meter, the temperature changes, but below the 2000 meter the temperature is same, around 4 degrees Celsius. As we are going deeper and deeper, heat is reducing, the intensity of the heat is reducing and the temperature also gets reduced. Sun rays are reducing there and there is no change below 2000 meter. Now coming to the next, salinity, children. When we see this graph of the salinity, it's per thousand sea water surface, like it starts from 34, 35, 36, 37 and 38. As we go deeper, the salinity starts from the 37 and the curve comes till the 34, and after 34 a big curve comes, 35 a big curve between 34 to 35, and after the 2000 meter it is again the stable. As we go deeper, the salinity also becomes the stable. It won't be changing there. Coming to the density, children, you can see it starts from 1024 and the curve takes place till the 1028. But again after 2000 meter depth, the change are stopped and it doesn't changes. As we go deeper, the salinity also becomes the stable. So we come to know that after the 2000 meters down or 1000 meter down, temperature, salinity and density all become stable, and that's what we are going to see, and we are going to answer in the question of the based on this graphs below. Children, here are the questions which are based on the graph what we have seen just now. So we are going to try to solve this, or we are going to answer this question. With the increasing depth, what decreases? Temperature, salinity or density? Temperature and salinity decreases with increased depth. What does the decreases? Temperature and salinity decreases with increasing depth. After what depth does not change, in these factors become almost zero. After the depth of 1000 meters, there is no change in all these factors. After the depth of 1000 meters, there is no change in all these factors. Next one is, till what depth is the change in this factor higher? The higher change can be seen up to the depth of 500 meters. The higher change can be seen up to the depth of 500 meters. Next one and the last one is, explain the correlation between all these factors, means the temperature, salinity or density. So here it is, if the temperature is less, density is more. If the salinity is less, then the density is also less. And however, temperature affects the density more as compared to the salinity. So the temperature is less, then the density is more despite less salinity. So it's all interdependent on each other, children. Children, as we have seen the graph and we have answered few questions based on the graph, you have seen the three different forms of the graph, the temperature, salinity and density. So here is a geographical explanation about the related to the graph about the temperature, density and salinity. The graph shows salinity, temperature, density with reference to the depth of the sea water. You know that density of the water is dependent on salinity and temperature. If you see carefully in graph, after a certain depth, there is no change in the factors according to the depth. The change can be seen up to 500 meters depth only. The slopes of the curves of the graphs are varying for all the three factors, that is temperature, density and salinity. Below the depth of 1000 meter, there is no change in all the three factors. Surface water is referred till the depth of 500 meters. The surface water gets affected by the ocean currents and sun rays. Movement of the surface of the water can be seen in the form of the ocean currents. At a greater depths, wind, sun rays, difference in the properties, ocean currents do not get affected by these properties. At around 1000 meter depth, there is no change in these three factors. Ocean currents are generated because of the difference in the properties of the sea water. They act as a temperature controller at the global level. The distribution of the temperature gets controlled due to the ocean currents. The climate of the earth get affected by the ocean currents, and these ocean currents get affected, children, by the upper layer of the surface of the sea water or the river or the ocean. So this is the surface temperature of the water, sea water. Whereas when you go in the depth, it is not at all going to affect. After 500 meters, there is no effect, let it be in any part of the globe, in any part of the earth. So the changes or the effects of different properties can be seen of the water only on the upper layer, that is because of the winds and the sun rays. Whatever the change, ocean currents flows or the waves flows, is because of till the upper layer only, till the 1000 meter depth, 500 after the 500 meter depth there won't be any change, it will be stable. Think about it. If you think about India, there is Arabian Sea to the west and Bay of Bengal to the east. The salinity of the eastern coast is 34%, while it is 35% in the Arabian Sea. What could be the reason of high salinity in the western coastal region? The reason for that is, children, mainly large peninsular rivers drain their waters in the Bay of Bengal, and on the contrary, only small seasonal coastal rivers drain in the Arabian Sea. Hence, you will find the salinity of Arabian Sea is 1% more than that of the eastern coast, that is of Bay of Bengal. Children, as you can see on the screen, the topic Dead Sea. So we are going to see Dead Sea. The name itself sounds like it is of no use. So we can get some detailed information about the Dead Sea. The name of the sea itself gives an idea of the condition there. The sea lying on the border of the Israel and the Jordan has a salinity of about 332%. The average salinity of the ocean is 35%. Jordan is the only river meeting this sea low rainfall. Low supply of fresh water and high evaporation are the reasons of high salinity. There is no life here except a few unicellular organisms. The fish coming from the river Jordan die as soon as they come here. Because of the high salinity, saline pillars have developed. Some of them come out on the surface. The density of the water is also high because of high salinity. Therefore, one can never drown in the sea. We can easily float when we go in the sea water. Another characteristics of the Dead Sea is that the land here is below the mean sea level, and it is one of the places having the lowest elevation on the earth. In some areas the altitude is minus 400 meters. So what does this sea name is Dead Sea? Why, children? Because there is no life possible depending upon this water. As you can see, the salinity is around about 332%, which is really very, very high, and it is situated on the border of the Israel and Jordan. Jordan is a country, children, and the name of the river is also known as the Jordan here, and it is only the river there which is present there. Okay, so the salinity of the ocean is 35%. It is the largest, Jordan River is the largest river which is meeting in this ocean. Okay, and the supply of fresh water is very, very low here. So that is the reason this high salinity is being seen, and because of the high salinity the density is also very high. So we come to know there is no life possible in this. Why? Because the amount of salt present in it is so much in the quantity that sometimes you can see in the low second one image, sometimes like this a bulge of or a pillar type thing of the salts come out automatically. So as soon as the fish from the river Jordan enters, the water which enters in this ocean mix with it in the Dead Sea, there you will find that they immediately die. So there is no life possible, the water is too hard. No, and even if we try to go into the sea, we won't get drawn into the sea because the water is very hard, full of salt, and that is the reason you will keep on floating on the upper layer of the sea water only. So these are the things which keeps us which tell us why the name has been given to the sea is called as Dead Sea, children. Let's see some more information about it. Continuing with the Dead Sea only, children, therefore one can never drown in the sea and we can easily float when we go in the sea. Another characteristics of the Dead Sea is the land here is below the mean sea level. It is one of the places having the lowest elevation of the earth. On the earth, it is areas as the altitude is minus 400 meters. So what you can see, it's going below the earth on the very lower level, and you can see in both the images how the bulge of the salt has been formed. So the evaporation rate is very high, and that is the reason you can see the water keeps on getting decreased, and the bulge of the mountain type or the big lump of the salt has been formed here, and low life is possible here. So we come to know why the reason the name has been given here, the Dead Sea. Thank you.